So looking at our water potential worksheet, I'm going to be working through some of these problems for you guys. So problem 1 says, if a cell's pressure potential is 3 bars and its solute potential is 4.5 bars, what is the water potential of the cell? So like I showed in our lecture notes, we are going to start by writing all the information we know. So we have our pressure potential equals 3 bars. Our solute potential equals negative 4.5 bars. So then our equation is going to be water potential equals pressure potential plus solute potential. So then we're just going to plug these numbers into our equation there. Water potential equals 3 plus a negative 4.5, which is going to give us, let's see, 3, which should give us negative 1.5 bars as our water potential there. So I'm going to write here up here. So we have our water potential of the cell equals negative 1.5 bars. So we keep that there for the next problem. So then 1A, if I can get this all erased nicely, 1A is asking, says the same cell is placed in an open beaker with a glucose solution that has a solute potential of a negative 4.0 bars. Calculate the water potential of the solution in the beaker and decide which direction the water will flow. So again, we're going to start by writing down all the information we know. We know that our solute potential is negative 4.0 bars. And then we do know our pressure potential as well. Because the problem stated that we are in an open beaker, we know that our pressure potential is 0 bars, right? So that means if we were to plug it in our equation, our water potential of the solution is going to equal negative 4.0 bars. So now the next part of the question asks which direction the water will flow. So we are going to compare them again. Or compare them now. So we have our cell, which is, sorry, I'll move up here. We have our cell, which is negative 1.5, and we have our solution, which is negative 4.0. So we want to decide which one is bigger. So negative 1.5 is closer to 0 than negative 4.0. So negative 1.5 is greater. So that means our water is going to move out of the cell into the solution. So our water is going to move out of the cell. And lastly, question B. So question 1B is then looking at our cell being placed in an open beaker, which means we have a pressure potential of 0 with a solute potential, or open beaker glucose solution with a solute potential of negative 0.15 megapascals. And then it tells us that 1 megapascal, so we're looking for what the net direction of water movement would be. It tells us that megapascals, so 1 megapascal equals 10 bars. So we are going to take this and multiply it by 10 to get it into our, get it into the same units as our cell potential so we can compare them, right? So this is going to equal negative 1.5. That is a 5 bars. Then we want to see which way the water is going to move. So we're going to calculate our water potential So that is going to be 0 plus a negative 1.5, which gives us of this, our water potential of the solution equals negative 1.5 bars. So we can see, if we go up here, our cell has negative 1.5. Our solution has negative 1.5, which means they are equal. They are at an equilibrium. So water is going to, there is going to be no net flow of water. We will have water going out of the cell into the solution and water going in out of the solution into the cell, back and forth at equal amounts. So that is how you work through problem 1. If you have any questions, let me know.